Everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In November 2025 lecture series, we are going to discuss about ECG characterization in biomedical signal processing under Unit 5, time, frequency and multivariate analysis. See here, first of all, why do we need to monitor ECG signal? We know that ECG signals acts like heart's electrical signature. Then what is ECG? This electrocardiography, which records heart's electrical activity through skin electrodes producing characteristic waveforms like P wave, QRS complex and T wave that are critical for diagnosing cardiovascular diseases. And while coming into clinical significance, here the ECG provides comprehensive multi-angle views of heart function, enabling detection of arrhythmias and myocardial infarction and other cardiac abnormalities. Here, what is the role of signal processing? In signal processing, advanced algorithms and transforms which converts our raw ECG signals into actionable clinical insights through sophisticated noise filtering. Here, which directly meets our output results like feature extraction and AI-powered classification using algorithms, either deep learning or machine learning algorithms. See, in our empathy part, our patient's perspective is very important and the clinician's requirements and designer insights. Here, in patient perspective, individuals with the cardiovascular diseases, they need reliable, comfortable and accessible ECG monitoring that extends beyond traditional hospital settings into their daily lives. And clinical requirements, which involves healthcare providers, they require accurate, easily interruptible ECG data delivered in a real-time scenario to enable timely diagnosis, treatment decisions and ongoing patient management. While coming into designer insight part, here engineers and designers, they play a crucial role like patient comfort factors and device usability challenges and integration of technology, which plays a vital role here. Here to understand empathy, we will play a role play activity. Here the students participate interview simulations alternating between patient and clinician, which really used to identify clinical pain points and opportunities in ECG monitoring systems. See, our core challenges are defined part. Here, how might we design our ECG system that seamlessly balance diagnostic accuracy, device portability and intuitive user friendliness for both patients and clinicians. Here are global impact and current limitations and innovation opportunity, which gives ideas into innovation part. Here, nearly 17.9 million deaths annually worldwide are caused by cardiovascular diseases. And our current limitation is most home ECG devices are limited to 1 to 3 leads, and here in this leads primarily detect the arterial infections and abnormalities. They are not suitable for which does not provide any high-end detection. Here, our innovation opportunity is we are in an urgent need for multi-lead and AI capabilities to detect the abnormalities of cardiovascular part. See here. Here we have advanced signal processing and wearable innovation, AI and deep learning and user-centered interfaces are generative, innovative solutions in our ideate part. See here, in advanced signal processing, we can implement noise reduction algorithms, wavelet transforms and automated feature extraction like P wave, QRS and T wave intervals for accurate diagnosis. And we have wearable innovations like ECG devices enabling continuous long duration monitoring without gel or skin preparation. And we can also deploy AI and deep learning, CNN or RNN. Here this transformer models which provides better identification for cardiovascular patterns. Here we have to ensure our user-centered interfaces for patients and clinicians. Here we can implement simple alerts, and for clinicians, for doctors, we can use detailed waveforms. We can incorporate diagnostic support for them. See. See here our mini ECG device development. Here are the key features, which includes wireless connectivity, onboard signal pre-processing and filtering, battery life supporting, and intuitive mobile app interface for data visualization. See. Here our clinical validation, which involves performance metrics, user validation, and continuous improvement. Here our assessment part, we have knowledge check part. Here students are going to complete a comprehensive quiz covering ECG waveform components, PQRST, signal processing steps, filtering, feature extraction and classification, and the 5 stages of design thinking applied in biomedical devices. See, our in-class activity, mind map creation and group discussion for signal processing application in ECG characterization. See, our final part, key insights and summary. Here we have discussed about clinical imperative and technological promise, integrated approach and innovation cycle in signal processing, how it is implemented in ECG characterization through AI. Thank you. These are all the references and for further reading. Thank you all.